Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with learnbay.co. Happy learning!
So there are like two, three, or maybe interchangeable words like customer churn, customer turnover, customer defection. At the end of the day, it mainly deals with customers leaving your company, right? And so we'll just talk about. So what do you guys think? Is it okay for companies to just ignore these people, or you always might think that okay, there are X number of customers leaving. Why don't I just get X of new customers, right? So why should I just think about this problem so much, or is it actually affecting the companies, or on how much scale is it important to companies? So any thoughts on that? Like anything that comes to your mind?
It's like depending on the customer who are living.
Exactly, that is one point. Like if it is, he has been a really loyal customer for so many years, so we cannot risk him to leave because he's been loyal. He will be loyal. So that is one point. Any other points that come?
Customer
Liquidate in business.
So yeah, that's
why few customers are leaving as a risk possible, why few customers show interest.
yes,
So,
yes.
why they are getting attracted.
Exactly. So what is happening in the ecosystem, right? Suppose Reliance comes up with a really amazing offer, like 1 rupee, I'll give you 10 GB, right? All the customers will just go to Reliance. So, but Airtel has to consciously know what is happening, what is the reason that they are shifting, right? So, so these are all the main or the main crux of this problem. One is competition coming up with really good offers, and second thing is retaining your loyal customers who has been like in US or other countries, they have internet connected to this. There's voicemail. They have these packages of buying phone. You get the voice with it. So it's a very suppose I'm with Airtel for the past 3 years. So I have given so much revenue for them for maybe just simple offer. I'm just leaving Airtel and going to Reliance, right? What if they give me that offer? So I will be loyal to Airtel. It's not I'm just leaving because I have some issues with Airtel or something like that, but they are also losing their loyal customers who might be with them for even more longer term. So on a revenue point of view, they will lose a lot of revenue if you lose the loyal customers that you have mentioned, right? Sorry, brand value, exactly. So suppose that also is a business point of view where companies are like losing customers at this rate, their stocks will be hit, their overall growth will be hit, right? So these are the business takeaways from this problem. And one more main thing that I will bring up right now is the cost of retaining an existing customer will be much lower than cost of getting a new customer. Any thoughts on that? Why is it? I think it's reverse.
Because you have to do it.
Exactly. So you have to do advertisement, you have to market, you have to do sales, you have to give them offers. Right? So Reliance is already giving a cheaper offer to get a new customer. I have to give them even cheaper or more or less on the same lines. Then I get a new customer, right? Now these number of customers are saying that we are going to, right? They have been with you for a long time, right? Why don't you just protect them instead of leaving? Right, so that is the main point here, where customer churn is a problem where the cost of retaining an existing customer is much lower than getting new customer. So that's why companies like Airtel or any big companies will always focus on this problem, where they want to protect the customers that they already have who are about to leave, who are at the risk of leaving. Okay. There are two types of customer churn. One is you can broadly categorize it as voluntary and involuntary. So as you told, there are certain reasons by which customer will leave from one country to another, right? So you would definitely change your provider. So all these reasons may fall under involuntary customer churn, right? So where it's sort of noise, where the data analyst will not be focusing more on those because we cannot control the customer's behavior, right? Where he is going, when is he moving, or any other logistical personal reasons. So we cannot control. But what about the customer who are leaving? Right? So he is leaving because he's seeing that okay, there is another offer. Maybe so these customers are given to the business are very important to business and will be given to data scientists, where they will be giving basically will be called call detailed records. So every call that is made for every customer in any telecommunication, there will be a call detailed record. What time the call originated, from which link, how did it go through, which are the hops. Like if you call from here to US, it won't directly go. It will go to first Europe, then it will go to US. Right? What are the hops that is going through, and what is the delay in the picking up the call? So the ring is at 1 second, he picked up at 5, so the delay is 4 seconds. Right? How long did they talk? The call duration, right? They spoke for 5 minutes. Some people spoke for like just 5 seconds, right? So these are all the details that every company will log for each call that is happening, and they will basically give you the call detail records, like of all the customers of that particular time. Suppose I give you call detail records for maybe 3 months, right? And I tell you, just tell me among these call detail records of these customers, tell me how many of them are going to leave in next month. So they will target those mainly, and they will give them special offers, right? And then that's the idea of how they retain them. So basically you have these terms like predictive analytics, prescriptive analytics, right? So the prescriptive analytics is where you are giving them an offer that, okay, hey, you know, I have a special offer. This is the coupon or something. I'll give you, why don't you use this, right? Instead of giving this to everyone, right? So using the data science tool, we will basically, narrow down that these are the people I'll give them offer because they are prone to leave, right? So that's where customer churn fits in. Okay. Any questions so far? Clarifications? How do I answer online? I'm not really sure if they are.
Definitely raise their voice.
So guys who are online, maybe you can also confirm with me that are there any clarifications or someone speaking? Okay, so I'll just move on to the next slide. So we'll just see how predictive analytics will help us with this problem, right? That's the main idea of. So you can just imagine customers as the water inside, and you can see how the cost of acquiring a new customer is expensive than the you just have to fill these holes at the end of the day, right? So you are just protecting the customers that are there. But if you see the upper vessel which is pouring, the dimensions is bigger. The amount of money or the revenue that you put there is much higher than just filling these holes. So you can just think this problem in that way, right? So basically that's the main.
Hello.
So that is the main idea of this problem. Have you guys got any chance to basically see the data set or the features or what is happening in that? I think I shared yesterday night. I don't know if you guys got a chance to see that. So basically we have 21 columns. Okay. So imagine I'm a company like Intel and you're the data scientist, and I come, hey, you know what? I have maybe 7,000 rows and I have 21 columns. And these are the customers that have left in this month or maybe 3 months. So I've collected these for the period of 3 months. Can you tell me who are going to, churn the next month? So I'll go and just, give them very personalized offers. Okay. So imagine the company has given you some details like this. So this is mainly applicable to companies in US and partly to India also now. So you can just see there's a customer ID. Right, so there's few things I'll just highlight here. Mainly the customer ID will be anonymized. So any thoughts, why is it anonymized? What is happening? Like any data set that you see where there is sensitive information, right? Mobile number, customer ID, SSN ID, if it's US, or any very personal information like related to diseases or medical health. Few fields which are very important will be anonymized. So any idea or any thoughts, why is it anonymized? Yeah, exactly. So when the data is given to a data scientist, they will make sure that I am not risking my users' privacy, right? What if Airtel comes and gives in the raw format the data that they have? So I have your phone number, right? So I can just use it for many other purposes. So the customer ID, first thing is it is unique, right? It is unique to all the customers, and it will be given in an anonymized format. So it doesn't have so much of value in feature engineering because it's unique. There's not much pattern that it holds between that and the target variable, which is churn. So the only takeaway from customer ID that you will get in any problem will be anonymized and it will be unique. So it is anonymized for privacy concerns and it will be uniquely identify back. Airtel has to identify back, right? You will say, okay, this customer with ABCD is going to churn in next month. They'll go back, they'll apply that algorithm of converting it back to, okay, with the person ABCD is XYZ in real, and they'll go and give them the offer, okay? Next is gender, which is pretty straightforward, which is a categorical variable, which is male or female. And then you also have senior citizen based on their age and particular threshold. After that, if you cross that, it's categorical 0 and 1. So you can see on overview or on a high level, so this data set features are mainly comprised of demographics. Okay, so what demographics is basically your gender, your location, your relationship status, or maybe your you have how many children and all, right? And on other things that are related to service, which are like online security, tech support, these are related to the actual companies providing, right? And at the end, you have few features which are related to billing, right? Which is total charges, the payment method that you have used for billing, and maybe the monthly charges, right? So at the end of the day, the amount you spend for the company is going to be one of the main indicators that, okay, you see that I'm spending so much high in this, why will I stay with this? I'll just leave this company and go to a company which is giving me better rate, right? So see, on the overview, you can see that the problem or the data set in similar cases or in such cases will always involve related to billing, right? Related to demographics, very important, and related to the actual, the providing that the Airtel has or any company has, like the internet service, multiple lines, phone line, or the data plan, right? So I think this is pretty self-explanatory. Any questions so far? Why do we have this? Why not this feature is there? Or any questions? Or any thoughts on this? Okay, maybe why only demographics of this, maybe not that. So if you go through the list, mainly you have partners. So if you are married, marital status, dependents, if you have children. So tenure, so as I was talking, tenure is a really important factor, right? So how long you have been with this company, right? That actually, is going to give you a lot of sense that who was a loyal customer, who is in this game just for a 1-year plan. So a lot of companies, you will see in the graph or the plots that I'll show you next, that a lot of companies are in this only for the initial period. So I'll tell you that till 1 year, why don't you guys use my plan and I'll give you at a 50% of the price. And then after that, people will leave, right? So they are only so it's important for you to identify how many people are such and how many are basically, going to churn after 1 year, right? After you will see after maybe like 2 years, you will see that, okay, the graph is basically just, there's a peak at 1 year. So you will just figure out, okay, why is this happening with the company? And you'll talk to the company and figure out that, okay, we are giving you a 1-year plan. After that, we are just increasing our prices back to the normal price. So all those will be very evident from the data, right? So as a data scientist, you'll figure out that, okay, yeah, so these plots will convey me all the business information that they are also, used to basically get the customers, right? Any questions? I think it's pretty so you have your payment method. Is it electronic, or you go there and pay, or the total charges, the amount that you have charged, the monthly charge, and at the end, the last one is where it is the independent variable that you are trying to find the relationship with these dependent variables. Somehow we can find some pattern with basically combining these and actually making a prediction. Is it a yes or is it a no? Like, is this guy going to stay with you, or is he going to leave you a service? Okay. So I think you guys are familiar with the process where you will first identify the data set, identify the fields that are given to you, try to understand what are they, and try to relate how are they relating to the business problem. Okay, so that is what first slide was talking about. Second slide is mainly we will try to clean the data, right? So, or we will try to basically do very simple operations, try to find if this feature is a summation of A1 and A2, then we can just go with C, right? If C is A plus B, then I will just work with C. It already has the data, or maybe I can make C into A and B and then see how they are responding to the model and how model responds to that, how I can graph them, right? Very simple things. Basically, we will drop the null values. So in the data set that is given, you will see that I think that I'll just go back 1 minute. I think one of the feature basically is empty, right? So you have no data. Any thoughts? Why will that happen? Or you might be thinking, why will I get empty? Why should I care about this data manipulation? Why will it have in a practical sense? Because it does happen in any data set that you get, there will be missing values or empty values. So why does it happen? Any ideas or thoughts on that?
The data
the source, the way they are collecting might have some issues, right? So exactly. So that's the main idea or the motivation behind having null values or replacing them, because we cannot control how data is collected, right? So I cannot say that I cannot work with missing values. It will come, it will be part of the data that is given. So one category, one column, basically total charges, which was I think the 21st or 22nd column that I was showing, has empty cells in the data. That if you look at the data set, what we are going to do is basically see how many columns next to that, the remaining 20, are empty, right? So if the total charges value is empty, and at the same time the monthly is empty, and like 4 or 5 columns are empty, like his partner status is empty, dependence, so I can just remove that field, right? It doesn't have a lot of information I can work with. So first what I'm identifying is there's a column which is called total charges, right? I will see if it has an empty cell, and then I go on to the left side of that particular row and see how much data is missing in that, right? If a lot of data is missing, I'll just remove that row, sorry. Right, so that makes sense, right? Because it has a lot of missing values, which is basically they couldn't get the details of the customer or somehow. So we can just, that is one of the data manipulation technique where we will get rid of this. Typically, if you have information on the left, only this value is remaining. So you can apply several techniques. Basically, you can substitute it with 0, or you can substitute with that with a mean if it is a values like 1, 2, 3, 4, or if it is categorical, you can just see how is the distribution and substitute it with the median. So there are other techniques, but at the same time, if you do not have any data at all, just get rid of that. So that will actually help your model trying to converge faster, right? Then you have some text, right? You cannot work with the variable like or the text field like no internet. I'll tell you how is this related. Now, if you take an internet pack with any company outside, they will also come up with the subscription for your TV, subscription to your other things like the landline phone, right? So if you do not have any subscription, all these fields will be empty, right? So when you do not have any internet plan with them, of course you won't have any online TV, online subscription to your landline, everything will be no. So that is one of the feature or one of the thing that you'll notice, that when the internet subscription is no, all these all these columns will be having no internet. So we'll just replace that with no, right? All the categorical variables like online security, online backup, device protection, tech support, all those will hold no, because they do not have any internet subscription, right? And there is yes or no for senior citizen, which you can replace it with 0 and 1. So can I ask you, like, why am I doing 0 and 1? Why not keep it yes and no? Or why am I just filling these values? Or what is my thinking or thought process? Why am I doing this? Any ideas? Like, why am I doing 0 or 1? Why am I not doing any other thing? Or why am I not keeping yes and no for senior citizen? Sorry? Label encoding. Yeah. So basically, we will try to encode it to some sort of medium or some sort of distribution. We cannot keep scattering yes and no there, 0 and 1. We will try to have some sort of uniformity. The main reason would be when you put this data to a model, right? It should understand, okay, this sort of convention was followed, right? And that will also help you when you revert it back to your user or the customer when you're predicting, right? So somewhere you use yes and no, somewhere you use 0 and 1, again you use no internet, yes internet. So it gets really confusing, or it will help you at the end of the day, and it will also help the model to converge better, right? I'll show you a little bit of visualizations between how this data set holds within itself. We have not gone to model. We'll just see how the values are within itself, how much percentage of churn is there, how much percentage of non-churners are there, how each column is related, like this column 1 is more related to column 2, or what is the correlation between each thing. And at the end, there's a point where I'm converting the tenure into 4 buckets. You can see the point convert tenure to categorical variable. Any ideas why am I doing that? That comes to your mind? Partially true. I want more, little bit more concrete answer. Yeah, exactly. So imagine I make a 1 month class tenure. I have how many? For 5 years, I have like 60. Right? How can I generalize? I'll have 60 columns now. Right? Now the tenure variable that is given in the data set will be like 10 months, 15 months, 20 months, 60 months, 40 months. I need to come up with some sort of bucketing system, right? That will give me more concrete aggregation. So this is sort of feature engineering where you're trying to club the tenure into mainly 4 parts. You can ask only why 4, I'll make it maybe 6 months. Well and good, you can do that also, right? It will be like double of this. So that's the main idea, basically trying to create them into buckets where you will basically create 12 months, 24, 48, and then maybe 60. You're also partially true where you can see how many people are loyal. So that is true, but how will it connect to the model actually? How will it connect to churn? Right? You have figured out that, okay, this guy is loyal, but how is it this variable connected to churn is what we are actually trying to see. Right? If I just give you only tenure and ask you how many are loyal and how many are not, then it would be the correct answer. But the main motto of this is basically trying to work with less features. Right? Basically a feature engineering step where instead of having 60 months or 60 columns, I am just making it to 4 or 5. That makes sense, right? Any questions on that? So basically, you can see that tenure is ranging from 0 to 60 or more than that. Like basically, it's month. So I'm just clubbing that into. I have few plots here, so you can go through the data and you can plot it on your own, or I can share with you after. I think there's another session where I'll share with you how I come up with this, how I'm approaching this. So then I can share with you my code, or you can tweak it, you can change it, or you can come up with this own plot. Is this plot, I think it is visible, or is it readable? Yeah, let me maximize this. I think it should be visible and clear now. So I've basically taken 2 things, right? I'm just doing some analysis. I have not figured out which model to use or what is but I'm just trying to see how the data is with me that is given to me, right? What is the percentage of customers that are churning and what is the percentage of customers that are not churning? That is evident in the plot number 1. Right now, for you, if you have to make a business point to someone, or you cannot give them a code, right? You would basically give a PPT with plots, right? So these is where you will come into that business perspective or business role where you're explaining to your CTO or CEO or business client that, hey, you know what, can you tell me the percentage of people that are leaving and what is happening? You said you're working with 10 years. Can you show me how is that plot working out? So you can just do this plot and explain to them everything. You cannot just give them a code or right, but the plots will actually give you a lot of information to you, to the business clients that you're serving. It will answer a lot of questions for them also, that okay, they will see for themselves in the data that they have given. On the left side, you can see there's a blue and green graph. 26.6% of them are churning. Right. So imagine the revenue that they will bring if they just protect at least 10% or 15% of that. Imagine it's millions, right? So you can just see how important it is for them to protect these customers, right? So the left plot mainly emphasizes that you are losing a lot of people, right? 73% are still there, but 26% are about to leave, right? Among these, if you can just protect 10% also, right, you can just save a lot of dollars, a lot of revenue. But imagine you have to get 10% more new clients. It will just be in a bigger scale, bigger number. So that's the main idea of the first plot, which is on the left. Basically to give you a brief idea how much of the percentage of people in the data that is given to you are leaving or about to churn, right? On the right side, basically I am approaching the tenure, whatever I'm explaining, whatever I've explained before. That on the right you can see visualization among the churners and the non-churners, right? So you have two categories: people who have left, who are still with you in the data set that I've given, right? So you can see in the customers that have churned, you can see what is the proportion who have left. So just focus on the 55.5, right? Can you guys infer something from that plot? Yeah. Exactly. So you will just break down to one of the business decisions that companies have made, that I'm just giving you 50% off till 1 year. So you see that 55% of that people have left. After the plan is done for 1 year, they have left. Right. So this plot will be giving you so many business insights, so many exploratory things where you can just analyze, oh, okay, this is happening. Oh, this is what is inside the data. Right. If I just give you the raw data, you have reached one step where you're plotting and then showing me all the insights where like 55% of the people have left within a tenure, 0, which is 0 and 2, 12, within 1 year. Right. So you can also see how many people are, with you after 60, which is the longest. I think it's little bit bluish, dark blue color. Right. In churn, 4.998. So what it means is there is very, very little people, like 4.98 of your customers are leaving after staying with you for 5 years, right? So I think that is very simple and very straightforward to understand. Do we have anyone asking for a question online? Okay. So any thoughts, any questions so far that how is this plot useful? Why did you plot this? What is happening? What is the insights I can get? Maybe you guys can see more insights from this. So you guys understand the motivation why I made a plot of this, right? From the data. You can just actually go deep dive and then say that 55% of the people are leaving. Why don't you, minimize that plan? Don't make it 1 year, just make it 6 months, right? You figured out 55% will anyhow leave, right? So why don't you can go and tell to the customer or the client right away. You have not done the prediction, but you have done some concrete data exploration where you have come up with the evidence that your 1 year plan sounds really good, but majority of just are in that only for the plan. They're not for the loyal customers, right? You can also point out, after 6 years also people are leaving. Why don't you figure out what is happening to them, right? 4.98 on the left side, you can see there's a churn customers, right? 4.98, which is the dark blue color, have been with you for more than 5 years, and they are also left. Why don't you go there and figure out what is the problem? What is the reason that you have figured out? So you will actually, make that 5 years, even 10 years or like 6 years, 7 years, because they've already stayed, right? Just figure out what is the problem. So mainly I've done few plots. One is on the left to show how much percentage is the customer churn. That is actually a really big problem to companies. 26% is customer churn, right? So I mean, we cannot make it zero. Definitely, there will be people leaving for so many reasons. But the idea would be to make it a small number. Even if you make it like 20 or 15, you have saved a lot of millions of dollars for companies, right? This is another, a plot where I'm plotting between the continuous values. So you can see the distribution, right? So where how these are interlinked with each other. So you can see how tenure on the left bottom, okay, how tenure is connected to monthly charges. Let me just go back to the code. I think that will be. I'll show it from here. It will be more clear. One second. Yeah. So if you just hover here, right? One second. Just compiling the code again. Just give me 1 minute. You guys all are aware with this Jupyter. I believe you guys are all aware with that, right? Anyone is familiar with Anaconda? Right. So can you just tell me what is that? Like, what is that going to help you with, or how is it beneficial using that? So this Jupyter is basically one or more. So I'll just show you. Meanwhile, when it is compiling, I'll show you this thing. So this is basically Anaconda Navigator, as you have told its ID. So what you'll do is, suppose you're working on multiple projects, right? So multiple projects need multiple packages, right? You cannot keep on, conflicting. This package was needed here, this package was needed there. So what you do is you create an environment and you figure out, for this problem statement, for this data set, I need 10 packages, right? So these 10 packages basically are installed here in this place. So you will open a Jupyter Hub, which already, uses these packages. Once you switch to another problem, so that remains the same. So these two environments won't, result in an error or something like that. So you can create another environment, install the packages that it needs for that problem, and work with that there. So if you need to install any package, new one, you can just go and install in that particular environment. So this is a handy tool I felt, where I think I can, bring up. Maybe you'll figure out, okay, this will be really helpful when you're working with multiple problems or multiple data sets, right? I think it should be done now. So these are just basically plotting the y value, the dependent variables in itself. You're not comparing anything with the independent variable, but how much is the percentage of this? Maybe how much is the percentage of genders? Yes, male and female. Like, is it 50%? 40%? Just trying to plot them and see how they are related to each other. So yeah, let me just scroll this top. So you can see here on the bottom that this particular tenure. So you can see the convention first. We'll just clarify the convention. So you can see if the tenure is 37, basically 37 is months. So that guy is not churning. Okay, so you're basically plotting at one guy at 44 has churn, right? That is only using tenure versus churn. Now, if I want to mix tenure with the monthly charges, you got the point, right? What is this scatter plot basically trying to help you or give you some inference business idea? So you will see that a customer with 27 tenure and a monthly charge of 55.5 has churn, right? So now you tell me, suppose you want to mix and see how monthly charges and tenure are related. So basically, it's a plot between connecting two, three dependent variables and seeing how is the distribution, how is that distributed. You already get a sense of idea that, okay, there's this sort of distribution, maybe I can apply this algorithm. So that is the main motivation of this analysis, where you will try to find out using this analysis that what is the sort of pattern that you see, right? At the end of the day, machine learning algorithms are trying to find that pattern, right? Once they find that pattern, when a new data point comes, they will give you a prediction. That is the main goal, right, at the end of the day. So you can see here how these points are connected. Like suppose you want to compare maybe monthly charges and total charges, these two. Okay, so a guy with a monthly charge of $67 and a total charge of 2,445 has not churned. At the same time, if you can go for a yes here, somewhere it will be a yes. So right, so you see what is happening, right? How are these related with each other, right? So that was the main idea of this plot. Okay. So I think any questions or any clarification, any confusion, like what is this plot doing? What is the idea behind this plot? What is the motivation of scatter plots?
But we don't get any solid conclusion.
Yeah, that is true. That is definitely true. How we do not get any solid conclusion, right? But you can get a sense of data how each are interrelated with each other, right? You will just get the sense. You will not get a concrete, solid evidence that okay, x equal to 1 and y equal to 2, then maybe some multiplication. But the main idea is to see how these plots can actually help you in a business problem or business way, right? You will try to make a PPT or make a business point of view and try to give them some inference or some idea to the customer or the client or the business guy or whoever has asked you. That is, what, see the scatter plot is something like this. So this will actually explain you how these are interrelated. Right? At the end, you will give the actual result, but you will show them the step by step how you approach or how actually you solve the whys and yes. Okay. This is another plot, basically, which is between monthly charges, total charges, and tenure. This is two-dimensional, but this is three-dimensional. Basically, you can see. So, any ideas or any thoughts you see from this plot? So you said you cannot get any concrete evidence or concrete result from here, but I can show you something that is concrete already. And anyone can figure out what is happening here. So the red dot is basically the customers who have left, and the green dot is people who are still with you. Now I have made a three-dimensional plot where it's between total charges, monthly charges, and the tenure the customer has stayed with me. Any ideas or any inference you guys can find what is happening? Just focus on the dots which are red. Any things that you can figure out what is happening from this plot? See, so you do not have a model right now, but still you already made some inference, right? Just by three columns, which is monthly, tenure, and total charges. So can you explain more how you figured that out?
Yeah, see, like tenure and
yeah, the red one towards the end.
Yeah. green are still there. The greener is IA and still there.
Exactly. Exactly.
But the early starters are
just going off. So the red part on the towards the bottom of this curve, that part, the below part where it's coming like this. So you can see they are all red. The concentration of red is high there compared to the reds towards that. So as he has mentioned, that you can see that just from this plot you have got a lot of inference, a lot of idea, right? So that is the main idea of why we are plotting, right? So now you also have some sort of concrete decision. From the scatter plots you thought, okay, yeah, they are related, but maybe you can just draw a line, maybe around some towards the peak. You already have a model, not a really good one, but you have a model, right? You can see, okay, if it is below this in this red region, I'll say this guy might leave. You're not giving a very good accuracy, but you can see where this is going. So you can build on these steps. You will figure out these features are very important for the model, right? So your model is not very concentrating on them. So you'll figure out from the plot, I saw that these are very important and I already saw the inferences. Let me change the model. How do you pick the model? Or how do you know which features are important for which model? Right? From this, you can actually make some sort of idea. Right? Any questions, any clarification, any confusion? You have any question? I think you have.
I'm not getting access of this array. 0, 10, again 0.
No, I think, wait, I'll show you in the code maybe. I think that is. Yeah. I'll just clarify that. One second, I'll just clarify that. It is 20, but since I got that image and put it in a PPT, just got combined. And it's a 3D, right? I cannot fit it properly, but I'll share the code or the way I plotted it. So you can just hover like this, and it will give you the 3 points: to monthly charge, total charge, tenure, and has he left? Right? I'll just go back to this. Okay, anyone can tell me what Pearson correlation is? Okay, I'll just break it down to simple things. Any idea what covariance means? Standard deviation. Standard deviation, I am expecting answers. Mean.
These are mean deviation from the mean average. How much?
Right. So standard deviation basically says how much the data that I have given to you is far from the mean. If the standard deviation is less, it's closer to mean. If it is more, it says that okay, the distribution that I've given is far. Okay, so we have boiled down what is standard deviation. Now covariance, any ideas? Covariance between two things. Exactly. So how they are linearly, or what is the how basically one probability or one distribution is more related to the other. Right. So you will see basically how they are. How much is there? Like, is it more? Is it less? The interrelationship. Now, how is that going to help you here? Any ideas? Just think it in the features.
You can drop the features.
Exactly. So drop and maybe create. At the same time, when you can drop, you can create more, which are powerful features. Right. Any ideas? Any other thoughts on this graph now? So I'll just define Pearson correlation is very simple. It basically uses standard deviation and covariance, and the formula is covariance by standard deviation of these two. Suppose you're trying to do Pearson correlation between monthly charges and the tenure. Okay, so the covariance between these two divided by the standard deviation of this into multiplied by standard deviation of this. Okay, that coefficient, if it is towards 1. Okay, on the right side you can see the green color. If it is greener, that means they are very correlated, right? They are very closely, they have a lot of information with them, or they are very closely correlated. If it is 0, so they do not have any, they are just random. So one guy is behaving in one way and one guy is behaving in another. There is no information between these two. Similarly, if it is -1, they are completely reverse, right? So this is again a plot to show you how the variables that are there, the 21 variables, are related to the another 20, like the 21 variables. Now it is pretty obvious the diagonal will be 1 because it's correlation with yourself, right? How is tenure related to tenure? Of course 1, right? But how is tenure related to maybe phone service or online backup, right? So this is another powerful plot which will give you a lot of information how these independent columns are related to other columns, right? So any questions? So you're clear about what standard deviation is, what is covariance, and how Pearson correlation is computed, and how is it relevant to these columns? How is this plot basically done, right? So this is the last plot I have, and I'll just talk about these models, or maybe give you a refresher. So we have got the data, right? We figured what are the null values, or what are the rows that we should clean, or we should keep them, we should replace them with mean, mode. We have done that. Third step was we basically saw some plots where we are seeing or trying to derive insights into that. Maybe column wise, only I'm focusing on column. What is the percentage of churners? 26, remaining 76. Okay. Then I went little bigger. How are these two columns related with each other? I've still not gone to the dependent variable, right? Then next step was we involved these three. How is tenure, monthly charges, total charges related to churners, the 3-dimensional ones, right? So we went step by step. We actually cleaned the data, we manipulated the data. In between, we also changed if it is categorical, make it 0 and 1, the encoding that you have mentioned. So all these steps are done. So the next step is basically the building the model or choosing the right model or which one we should choose, right? Since you guys have completed the course, maybe you guys can help me. What is accuracy? What is precision? What is recall? What is F-score? How is this related to this problem? Maybe one by one we'll go. Maybe accuracy. So what is accuracy? Very simple question. So I have my training data. I have my test data. So I have only my training data.
What's the difference between training data and test data?
Okay, so that's so basically any machine learning algorithm will try to learn its hypothesis from training data. Okay, and then it has to see something which is unknown, right? You cannot just make a model for this data because you will give this model to a customer. He will keep on testing. New customer has come, is he going to leave? So the testing data is basically the data that model has not seen, right? So there you will see what is the accuracy. If the accuracy is bad, you will say, no, this model is not very good for it. You will start using another model. So that's what we'll see in the next session. How I am choosing among these models. Is it decision tree should I go for? Is it logistic regression, very simple one, or I should go a little complicated ones like SVM or XG boost or light. So what are the factors that actually are helping me boil down to which model to use? So one among them is accuracy.
And one more thing that if suppose training data is different from test data, so result will be very different. You cannot say that.
Exactly. So ideally they both will follow the same distribution, right? So I gave you data now. Now how will you create test and train? You will just split it from 80-20. So they will inherently have the same distribution. But I give you data of Airtel and ask you to test it on Vodafone. They are different. It doesn't make sense. So the training or the testing or the model building will be basically following a split 80-20, 70-30, 50-50 sometimes. So whatever it is, you have to keep in mind the distributions of test and train are always same. You are not building model from one data and testing. It doesn't work. Of course, it will fail. Any questions on training, testing, accuracy? So we have established what is accuracy. So out of 100 churners, my model says that 90 of them are actually churners. So the accuracy is 90%, right? So my model has actually told Airtel that correctly out of 100, 90% it has done really well. right? Now, is that enough? Like if I just go and like make it okay, this model, so why is that not enough?
We want more accuracy.
Okay, that is one thing, okay. And what if I say there are other business decisions also or other metrics to also check? There's a nice problem I'll give you right now. So as you guys saw the data distribution, churn is how much? 26%. Non-churners are 70%. So I make a model which will say always churn is yes, no. How much accuracy I'll get? No. So in the data of 100 people, 26% are churners who are going to leave. Okay, remaining 74 are who will be with you. Okay, now I am not actually building a model, but I am telling you everyone is going to stay. My model will always say everyone will stay. Now, what is the accuracy there? Yeah, 76. That's the accuracy. But I am not accounting for the 26, right? Right. So that's where other metrics come in, like F score, precision, recall. So that's the main idea. Like why you not only can see accuracy. Accuracy is 76. That is already given to me in the data. I have not made it better. So as you told, I should make it even better. I'm not only telling people who are leaving, I'm also telling people who are not going to leave at the same time. That's where precision, recall, F score, and are you familiar with type 1 error, type 2 error? Right. So type 2 error is recall. Right. Anyone can. Yeah. So basically in hypothesis testing. So that's what I was telling you. Only if I see accuracy, I'm going to, be in a very big bad situation. I'll make a model and give you, what client, the accuracy is 95% excellent and all. He'll be also very excited and try to see, okay, but there is bad F1 score. So I'm telling everyone is going to stay. But my problem is trying to solve who is not going to stay, right? I need to focus. Then F1 score will help you there, right? So these are the different metrics that you would basically choose your model from. Which model to use, what is the accuracy of all these models, and what is the F1 score of all these models. Among those, two are performing really well. One is maybe decision tree, one is logistic. Among them, again, you will figure out which one to use. You have narrowed down from 5 to 2. From 2, you have to use 1. Now, what are the other metrics that you will use, right? So, decision trees, for example, are very unstable to the data. Like if there is a small change in the data set, the new data that comes or the data that you're training, the whole tree will change, right? So the tree structure is built on all these factors that little change in the tree structure will change the whole orientation. Whole point is, right? If your company or the client is not very happy with that, you will not prefer decision trees, right? So the business decisions come in now, where which model to use against which model, right? Any questions? This is actually a little big slide. There are so many things in that, so I'll just go one by one. So one is logistic regression. So I think everyone should be familiar with that. It's very simple and straightforward. Can you guys maybe tell me, or do you guys need a refresher? What is logistic regression? How is it applicable to this problem? Linear regression, logistic regression.
Of course, yes. You've studied 2 months of a year of forward.
Okay, so that's cool. That's why I was asking. Maybe I'll give you another refresher. So in linear regression, what we do is try to find a line which will fit the curve. Very simple algorithm, very simple to explain to anyone. Now this line will give you a value, like you have maybe house area and the cost of the house, you have points and then you plot them. House area, maybe new point comes which is like 100 square meters, and the cost you'll say $20 or $2,000. But the problem that we are working right now is not giving me a value. I don't want the value. I want me to tell me if the customer is going to stay or leave. Right? It's a yes or no. How will you convert the value that you have given to yes or no problem? You see the gap that logistic regression is building. So the linear regression is basically giving me a line. You take one point, it will give me the cost of the house. That value is good, well and good. but I don't want that value. I want to tell me if that value is high or low. You will put a check. If this value is more than $50,000, it's a high priced house. If it is less than $50,000, it's a low priced house. So that's how logistic regression is little bit ahead or a one step change from the linear regression. So basically you will say if the customer tenure is this much or the model value that is predicting is this much and it is above some threshold, like 50,000 I took for the house price, right? If the probability that I'm computing using the logic function is above 0.5, I'll tell that this customer might leave. If it is less than 0.5, I'll tell this customer is going to stay. Right? That is the main difference between linear and logistic. Okay. There is another model that you can actually tweak the logistic regression and use different variations of that. It has lasso, elastic net. I think you guys can read up on that. But the main idea of logistic is you don't want the value, but you want to categorize it into is it high or low, yes or no. Then you use logistic. Okay, is that clear? Any doubts? I think you guys can remember it now, how logistic is being taught, and you guys can understand now what is logistic regression, right? Now next is decision trees, right? So I'll just show you a very directly how decision tree is built here. You will just remember it. See, so this is how it looks. You are trying to ask me, right? How the visualization looks. Now for X, which is monthly value 104, and Y, which is total charges, and Z, which is his tenure 58 months. The ID number of that customer is this. Red is, for example, is churn. Right? So much value of information is there just from this plot. Like you can see, these guys are all churning. Right? But once we cross this barrier, we see green. Lot of green. But here there's a lot of red. Just by this plot, so powerful that you can just make so much deduction. Okay. So this is how a simple decision tree looks like. You have your decision tree. So let's just split it into two words: decision and tree. So it is a tree. At the end of the day, it will look like a tree, which has a root node. It has leaves. Okay, and it is deciding at each point. Suppose this is this, I'll do this. This is this, I'll do this. So what it is deciding on the top, the value that I've given of the customer, if it is tenure is less than 16.5, then I'll go to the left. If the tenure is greater than 16.5, I'll go to the right side of the tree. Okay. So like this, it will once it goes to the right side. Now suppose the tenure is maybe 20, which is greater than 16. Now it will go to the right side and see if it is monthly charge is less than 69 or greater than 69. Right, you can see how it is boiling down. It will go through that tree structure. At the leaf node, it will give you the probabilities. Okay, is this clear? How a decision tree looks? Okay. So, any confusion, any clarification? I think it is pretty clear because I have shown you the diagram. I think you guys should remember what was taught or how is it, how it works. Now the next algorithm that we will look at is random forest. Now what is forest made up of? Trees. So it's pretty simple to understand or remember. So random forest will have a lot of trees. Now decision tree will work with only one tree. Random forest will work with many trees. Right. So internally, if you see here a simple example. So this is only one tree still. So here you can see a lot of trees are there. Right, if I scroll within, so there is one tree here, there is another tree starting here, another tree starting here, right? So random forest basically divides the data into smaller parts, builds trees for that individual smaller parts, okay? So random forest is like the versatile algorithm in ML, machine learning. It works for categorical, it works for continuous values. So categorical is where the problem is yes or no. Continuous is where the problem is, tell me what is the amount of house price. You will be a value, right? You know the difference, right? So random forest basically is like really, very simple and very ubiquitous, like where you can use for any sort of problem. So we will use that also and see how it works, right? So I think you guys are clear now, like what random forest is made up of. It is basically made up of individual decision trees which are built on individual data parts. Suppose I give you 100 rows, split it into 10 and build a decision tree for 10, and the decision, right, it will consult all these trees, and then at the end it will merge and give me the final result, right? That's how random forest works. Okay, then I'll explain that while I'm presenting, maybe or maybe showing you the code or how I'm explaining. The light GBM and XGBoost, basically they are also decision trees. Actually, XGBoost is from Microsoft, where there is a technique of boosted decision trees, where you have random forest, you have split the data, you have trained individual trees. What boosting does is basically it learns which are weak learners and which are strong learners, right? Among those 10, when I'm conversing internally, it will say I'll ignore this first guy's input because I know he's a weak learner, but I will focus mainly on 6, 7, 8 because I know they are strong learners. So they know they will give me very good accuracy. So that is basically using the technique called boosted decision trees. Okay, so these are the set of algorithms that we will be experimenting, and we will try to boil down to which one to use based on accuracy, precision, recall, and F1 score. Any questions about these algorithms? Any clarifications? Anything?
If someone would ask actually which algorithm will you use?
Sorry?
Someone asks which algorithm, which model will be used for customer side. So our answer will be we will put one straight in which algorithm we use model.
Precisely, exactly. That's really the end result of this code or the end result of this session, because you will run all the models, you will see, but you cannot say based on accuracy I'll just go with random forest. Wow, very good. No, because you need to consider all the business decision, precision, recall, F1 score. Based on that, you will see which model is doing well among all these categories, not only accuracy, right?
That is for all.
Exactly. That will be the main idea between all the ML algorithms, or how will you decide between them. There are other factors that will, I think everyone understood how you narrow it down from 5 models to 2 models to 1 model. Okay. Towards the end, you will actually consider business decisions also, like how fast is the accuracy, right? Trees, if for example linear regression or logistic will give you in 1 second, but tree, if it is very big, if your forest is very big, it will take some time, right? So you will be like, okay, client is very interested in a very fast result, then you would not prefer trees, you will just prefer with regression, for example. But he just wants a really good answer, he's willing to wait, then you will see trees are a really good problem, right? So in the next session, we will basically go through the code, how I have come up with that plots, and then we will basically help you how we can narrow down to which model. Maybe you guys can come up with your code. You can use SPM maybe, for example, and see how it works out. How is that applicable to this problem? What is your accuracy? What is my accuracy? Are you getting more accuracy than me? We all can figure out together how it works. Any questions till now? I think it's quite some time now. I think more than an hour and 15 minutes, close to an hour. Any questions so far? Any clarifications? Any doubts? Anything? F1 score, what is precision? What is recall? Why are we using this? Why not only accuracy? What is that helping me with? You guys understand why I'm using not only one, but other features also, other evaluation metrics to be, correct word is evaluation metrics, right? How am I using all these?
Can you go to the previous slide?
Yeah. This one? This one, Pearson correlation, sure. So you're clear about standard deviation, right? So what is standard deviation?
The mean deviation, output of the mean depends on the reaction of the two. If it's less, it's okay.
No, so we'll just focus on standard deviation, not Pearson. You're telling about Pearson correlation. Just we'll go with standard deviation. Yeah, how far the data point. So I give you values 1, 3, 4, 5, 10, 20. Mean is maybe 12. Right? You will see the distribution, how far these points are to near the mean or away from the mean. If your standard deviation is less, it means the points are very closer to the mean. Okay, it's clear, right? Similarly, what is covariance? Covariance between two x and y. Like how are they dependent? Like monthly charge, if we have club for next 12 months, you will get yearly charge, right? So yearly charge is correlated with monthly charge, very high. But at the end of the day, if you see yearly charge with gender, they may not be very much correlation because they are not so dependent or correlated values, right? So in the data set that is given to you, there are 21 columns, right? Like tenure, there is gender, there is internet connection, yes or no, what is the tenure, what is the monthly charge, how many dollars you spent, how many dollars you spent per year, right? So on the left hand side, on the bottom, it's a matrix of same 21 by 21 rows. Okay, the diagonal will be 1. Why is that? Because what is a Pearson correlation with itself? It is 100% because I'm completely same as so that's why in the diagonal you can see the elements are yellow. Okay, yellow is basically the scale 1. On the right hand side you can see a bar. Okay, now this other dots, for example, I'll show you. I think I'll show you here. Maybe it is very clear. It will get clear to you. Okay, so this is the plot, right? Now I'm comparing streaming movies on the x-axis. Okay, x is streaming movies and the y is contract 1 year, for example. Okay, these are the two columns that I'm trying to see how well they are related or not related. The Pearson correlation comes to 0.64, which is closer to 1. So they are correlated, right? You get the idea behind this plot. Suppose I go maybe here, -1. They are opposite, poles apart. One guy is increasing, one guy is decreasing, one guy is decreasing, another guy is increasing. We will see something which is close to 0, for example. You can say this is close to 0, 0.16, right? So contract month to month, if it is yes or no, versus paperless billing. So they are not related. They are very two separate things, billing and subscription, right? So this plot will basically give you so much inference or so much idea how each individual columns are related. Does that answer your question? Any other questions you have? You understood, right? How each column are related to each other. Very simple. When you bring the main guy, which is he going to leave or no, then that is the three-dimensional plot here. The one I was showing, the 3D one before, this one. So when the monthly charge is this, total charge is this, easy sticking around. 3 variables are there, 3 axes. But here I'm just only 2 axes, which is X and Y, like how is the tenure related to monthly charge? Any questions? So I hope this plot is clear, right? We're just comparing how 2 columns are related to each other with every other column. Okay. Any more questions? I think we can stop here. I'll just ask online. Guys, are you there? Any questions? Maybe you can ping me in the chat. Okay, I saw from Stuti Gupta. Any other guy? Any others? Sorry, I closed it. Thanks, Vinod. So the next session will be the code part, the real thing. Till now, we have not come up any concrete, but we have a lot of knowledge now. We had a data set of 7,000 versus 21 rows till now. We had no idea. I just gave you some CSV file. But at this point of time, you have seen so many relationships with each other, the columns, how we approach, what are the models that we have in our mind, what is the approach we will select for each model, what is the data manipulation we will do for each other. You guys are step by step, we will do that at each block of the code. At the end, I will show you a plot of how each model is doing for each with respect to so many parameters like F1 score, sorry, precision, recall, accuracy. Then we'll pick which model we'll choose based on the business decision. Right? So that would be the second session.
What is it? F1 score?
Okay, so that's a good question. I was just wondering, no one is just bringing that up. So F1 score is basically a relationship which compiles precision and recall. Now you have precision and recall. Now if you ask me, is there a metric which actually encapsulates both of these in one metric? That is F1 score. So F1 score is basically a harmonic mean of precision and recall. Now when you're doing a model selection, okay, you see the matrix, there is precision of one model is 1, precision of, for example,
Confusion matrix.
yeah, confusion matrix. In that you will see the precision and recall percentages. Okay. Now how many times will you see that? You need a one unified score, right? Which you can just go to and pick. Suppose I was working on one problem where the data was so skewed that the categories were 4. Okay, A, B, C, D. A was 1000, B was 100, C was 20, D was 5. Now F1 score of all these, if I just see the precision, recall and accuracy, everything will be high. But these guys, F1 score will be pretty low. You understand, right? F1 score will see how it is performing on the categories which have less data also. Right? Precision recall will see how your accuracy is, true positives, false positive, what is a comparison. I think that is pretty clear. But F1 score will be evaluated when you have data in this fashion, 1000, 100, 20, 5. This 5 will never be coming, right? It will always say 1000 category A, all the model will say A. But F1 score will be very low, but the other metrics will be pretty high. You understand why we use F1 score in which situation? So it's more in this, Stuti, I'll just answer you in 1 minute. In this problem also, if you see, we have two categories: people who are going to leave, people who are still with you. 76% versus 26, right? The ratio is not healthy. It's fine. Well, many algorithms will figure out, but among those 1000 points, only 5 points are hiding somewhere. You will just mask them as 1000. Like you will just say they are also A. But the guy who is interested is very specific about those 5. Then I'll use F1 score. I'll just make it very clear. Suppose you have inbox, Gmail, spam, right? Now spam is how many? Like very few, like 10, 20 mails. You get thousands of mails every day. But I have to classify which is spam very correctly. Then would you use accuracy? Accuracy will be very high because you are saying this is not spam, this is not spam, this is not spam. Even the ones that are spam, I will say this is not spam, this is not spam. It will be 99% is correct for you. You'll be like, excellent, let's put that model to, we will give this to customer. But he will like, no, wait, I'm interested in which are not spam. Why are you showing me that? Then you see F1 score is bad for you. I will say, hey, you know what, don't look at accuracy there, look at F1 score. Because F1 score will see precision, recall, the number of categories you're working with, average it, and then see. F1 score will be very low in that case. Because you have 0. The ones that are only 5 among like 1000 will be saying, oh, this is also not spam, spam. All of that will be 5. 5 basically you have predicted wrong completely. So the F1 score component among them will be 0. So the F1 score will be drastically like reduced. Accuracy, precision, recall, everything is good. Good as in like more or less okay. But F1 score will actually see everything. That's the reason we use F1 score. I actually have this code written in Python. Yeah, I need to write the complete thing in R again. So the plots and the code. Code will be more or less similar because you'll call the model. Here it is sklearn. There it will be maybe cart or something like that. But the plots I need to see. So it will take some more time for me to come up with the R code. So I think Python is where I have been working for past 4 years. So that's the reason I have chosen Python directly without a doubt. But I think you guys have been taught R and Python at the same time. So I think that's why she was asking.